So just be sure how many people can understand what I say right now. Everyone can understand? 1, 2, 4. I'm sure more people understand me. No? All right. I will try to speak slowly. So let me know if you have any question. So today we'll talk about two stories. It's about how we use Kubernetes and how Keda is using it, and also Kubernetes Autoscaling. So, right. So this is one of my favorite codes. Make it right, make it work, make it right, make it fast. From Keda.sh. Who knows about it? So it's like a very good code. But you already like refer to it at buffer. So the problem is like most of the time, most of the people just work that are make it fast. And this happened to us many times, and we have like a lot of.
How do you share?
In blue jeans. Where's
There is blue jeans?
Yes. And
okay.
Yes.
Sorry, forget the largest one.
Okay, going.
So yeah, a lot of people focus on make it work, and then fast. We do it quite often at buffer, and sometimes we don't really spend time on it. Right. So I mean, this like this code is, I think it's about coding and about adding pairs and something about the right to do this in the infrastructure side of things. And yeah, so I work at Buffer. Who know about Buffer? Buffer? No one knows about Buffer? Yeah, right side. So we do a social media. Or whatever, inside Buffer, and you can manage all your social media. And these are how much money we make. So we're quite famous for showing egg or how to spend dollars. We're making like 20 million USD a year now. We have like 70,000 customers, and we have few million users. A few millions. And this is our team. We're all working remotely. So I work from Taiwan. There is actually people in Taiwan too, and most of the people are in America, Europe, or London. So work remotely has been like 8, maybe 10 years for working remotely. So it's like quite cool. So I'm Eric. I'm doing infrastructure. I do like kind of things, observability, data pipeline, Kubernetes, what is kind of doing on my job. Right. So this is our infrastructure buffer. Okay, so it's not really clear, but basically we are using Kubernetes on AWS. We are using Keda.sh. Who knows about Keda.sh? Keda.sh. We're not using AKS. We're thinking to use it, but we're still testing it. And we're using Keda.sh to manage Kubernetes ourselves. And we have like a little bit of BigQuery. We use like MongoDB as a database. We don't host it ourselves. We use MongoDB. We're really good at it. And yeah, for the data side, we have BigQuery and Bash. Yeah, basically. And we also use Cloudflare that help us like. I'll jump it to the right endpoint. It was like in 2019, but I don't see much. And okay, I wanted to talk about one of our main pipeline flow. So this basically represents maybe 50% of our cluster. So basically, producer consumer things. So what we do is okay. So we have like many events from users, from webhooks, from schedule jobs, from cron jobs that send like information to some queue. Those queue like host some message. Maybe I will slow down a little bit to know about SQS here. SQS, Kafka, it's like a Kafka thing, where you can like store messages. So this like SQS is like a really big for us. So yeah, we have like many events that go to SQS, and after like we have like a lot of contributors like worker A, worker B, worker C, and they do like all kind of things. They do like they can send or whatever kind of jobs. So this is like a really important one for us. And you can look like this. This one of the one I gave a talk last time at MyCoin. I don't know if some people have been MyCoin told me to talk. I also gave a talk last time. Yeah. So this is a QR code. If you want to check my slides, it's there. And this one was one of the data pipeline I was talking about because I did like something from PHP to Golang. And Maxence helped me to do it. Maxence is there. Anyway, the thing is like, okay, for one of this pipeline, so this one of them can make like 4 million USD a year. And this was in 2014, but now it's making almost 20 million. So this is why quite important one. So yeah, and so this is how this pipeline looks like. It's quite basic actually. It's basically it's like so our main job now is like to send data. So people when users say, oh, I want to send I want to post. Just start the event on MongoDB, and then they set the time, whether they want to say it now or set, but most of the time they want to set. And this we have a cron job on Kubernetes that just aggregate all the posts we want to send, and after we store this job into SQS, and then we have a worker that grabs this message and then just makes the job to send it to social media. And yeah, so it's sending like to LinkedIn, Instagram, Twitter. That's it. So this thing is like a address. So this is pretty good. And so what is interesting about the story about this data pipeline? And so Joel is our CEO right now. So he started the project, like it's a side project actually. We started it like in the UK. We just like hosted this data pipeline on a Meetup, on a 20 USD Meetup server a while ago, and then after the company started to make money and all this kind of thing. And after like there is a team who joined him and Sunil was to migrated this from job because we have like more users, more posts, have more customers, and people are like, oh, we need to send more posts to social media. So we just put everything into Elastic Beanstalk. You know about Elastic Beanstalk? Elastic Beanstalk, yeah, I like it. It's quite nice actually. And he puts everything onto unsupervised to make sure that. Then after I moved this pipeline to Kubernetes because we're like this in 2017. And we're putting this cron job into the cron job controller. Who is using cron jobs here? Oh, so I have a question for you. But yeah, this basically is the story of this pipeline. So before, I mean, I don't know how it looks like into the server, but this was like just prompt out. And Amazon insert like just looks like this. Now it looks like this. So yeah, this thing is one. So it's really basic, right? One can say about it, just resources, the command, and just the cron job. So at what scale do we do this? We do this at about 3 million SQS message per hour. This is not only social media and third party, like everything. So it looks like this. And this is about like 20 cube, but have a lot more. So this was just accumulation. Did all of this. So what's interesting is like different cube have there. So we don't only send this to social media, right? We do other things. So all these patterns represent different things. That is cool. So there is like Khun is my manager. and he asked that some time ago in guest, asked me, hey, are our queues really efficient? Do we consume those queues efficient? And I was like, I mean, this was just a question, right? Because yeah, there's some. Wow. And I was curious about it, and he set up a dashboard. I was just checking it, and we were like, oh, actually, we are like quite bad at doing it. But the thing that I was curious about was the formula he used about how he calculated. And he used like two metrics. He used like the deleted number of messages deleted. So the number of messages deleted are when you grab a message from the queue, you process it, and you delete it. So this is like a full job, right? So this is good. And the other metric he used was the number of empty. So who knows about the number of empty received? So I didn't know what it was, because I was like, okay, what is this thing? I never hear about it. It was quite good. And when I went to check the documentation of Amazon, so it was like basically the number of message applicants that did not return a message. So what does that mean? That means they make a query to Amazon, and nothing, and something is returned, but it's an empty array. So nothing. So it's just basically a point of how many messages that have nothing, and not messages that have nothing, the applicants that have nothing. And so he used basically this metric to say, oh, so if basically you have more workers that consume this queue, so it means you are over provisioned. Does that make sense? So, I mean, it was a smart metric, right? Like, oh, okay, so we have more workers than what we need, but how can and all right, I mean, it was like pushing, but I was curious about, okay, so what is the most, how to say, over provisioned worker? I started to check like all those queues that we have, and I ended up with this thing. This is like basically all the queues that we have right now. So I mean, of course, this is the top 20 or something like this. Quite interesting one, and it's like, well, one of the queue was like, this one, it was like, oh, like 60,000 message. Yeah, I don't have the scale, but it was quite a bit. And I was wondering, okay, so how many empty message do we have actually there? So I ended up with this thing, like the sum of all the vehicles that were empty. So it was like about 160,000 message per 2 hours. So I was like wondering, okay, how much did that cost? And this is my person. I thought, oh, this looks like a lot of costs, right? I was like, oh, right, and Amazon is charging, but I mean, it's just like API costs, it shouldn't like cost that much. And actually, Amazon is charging about 1 million API calls for 40 cents. So the problem is like, when we put this, how many empty calls we made was like 7 million calls a month. So it was quite a lot, and it cost like about 25,000 USD a year. So it was like a big problem, and I was like quite upset about it. I mean, no one knew about it, and we just discovered that I was like I was like just putting a message on Slack and say, hey guys, I have this problem, and yeah, so we just like I started posting this message. What happened? Like, oh yeah, so maybe we should do something about it. Started to do something about it, so I started digging into the documentation about the messages. And so I was like, so what's interesting is like when I forget to post time, the second link that appeared at how to save money on. So it's pretty interesting. So basically, it's like the solution was like to use long polling, short polling returns, long polling return instead of a short polling. What we were doing is like basically we make a query, and SQS replies to us directly. Hey, there is nothing. Hey, is there something? No, there is nothing. Just what happened for many time. And Amazon recommend actually to just use a long polling techniques. So there is like, so basically it's like when you make a query, if there is nothing, there is just this, I don't know what they do on the side of sleep, whatever, and you just wait until there is a message when you return. And yeah, long polling doesn't return a response until the message arrives in the queue. In almost all cases, SQS long polling is the preferred way to do it instead of short polling. So this is what is in the documentation. So what's quite interesting, I want to it, so that's really interesting. That's how I like to do my job and just do okay, let's try that and that. That's really fine. So repository. I was quite lucky, I kind of knew how works all services, so I could like make the change quite easily. See what happened. And yeah, so what was my the thing that there is not the thing that you can change this into the code, but sometimes there is some framework that will follow it. I forget the name of the framework, but there was some. I was like trying to change the code, trying to find how to change the SQS library to make kind of things that sometimes at this time we have like to go to the console and click on the SQS and go queue and just add this message wait time. So it will basically wait 20 seconds until you return the message. 20 seconds is like the maximum that you can wait on more. What was the result? So this was the result. And so from 160, I guess, I couldn't do everything. The changes, so this is what happened. So now we have like almost none of services. Yeah, almost no everything. And this is the best thing that happened. So you can see like on the daily, this is a daily graph of how much we spend on Amazon on SQS. So we're like spending like about 125 almost, 125 a day. And now the cost is like reduced to 50 USD a day. So it's like a lot of money saved, right? So the other thing we didn't really think about, it was like a really nice side effect. So by reducing the API cost of the workers, we just saw like some significant like and more usage. So this was basically this change, I guess, here. But here, so it was really good. And what's interesting is like also the social metrics. Who knows about CPU limits and social? It's an interesting topic. I'll write a good podcast about it. But it's a really interesting one because the thing that this one, so what means the CPU sloshing means, okay, so if your container is trying to do some work and set some limits and it's reached like this limit, Docker will try, or Kubernetes will try to slow down your process and to just create some sloshing. So what's interesting is like you might believe that maybe you need more workers, it's all there, I can see sloshing, right? But actually, no, because it's just making some API calls for doing nothing. So it was like really misleading, so it's kind of interesting to just point to this. So yeah, we save some money, we save 5,000 a year. Yeah, it's not Taiwan is it's crazy. This space can become really expensive for. So it's interesting, we're like paying for doing nothing. So this was my conclusion that we did. And for the past 8 years. So it's not just a one-time thing, it's like we didn't really scale. I mean, we'll have more workers, I guess, but I mean, I'd be a little bit less. It was really big first time that we found it. So we set some money, less CPU usage, less load thing, it's misleading as I told you. And so what's good is also like, oh, we need like less resources for the container, so we can like plan like more. So we need less nodes and can like plan more ports into your. Yeah. So why? That's a question I like to ask myself, and I think this is a problem. Default options. So when you go to see the documentation and see like Amazon provides a SQS short polling and long polling to basically, by default, we use the short polling way. So that's the problem, right? So when you create something, you don't really say, oh, this is the default option, oh, it's working, and just working, right? That's, you don't need to do more, right? So this is what happened to us. And so that's the thing, like, we're never questioning what was working decently or just questioning the way it has always been done. I mean, it started like, it was set up like 8 years ago, and no one really went to do it, and just, oh, is it like, we're going to do it actually? So, yeah. What could have helped? So, we are like wondering about, I mean, this is just a site for like things that we have like waiting something. Like if you are like using something like Terraform or something, you have like set option or this kind of thing. So maybe we'll figure out, oh, what is this option and try to integrate a bit more into it. I think, yeah, I think there is also difference there. But I'm sure you have like figure out something over that. So SLI, SLOs. So who uses SLI, SLOs here? SLI, SLOs? No. So it's like a way to define your service, what services are important, and just put digits into it and just reevaluate it constantly. So maybe a will figure out. Also, what's good here is if people don't know that Amazon is here now, it is good to know because I want to see them and just ask them to help me to make some review of my architecture. They are willing to do it actually. So it's good if you are only paying for them, so it's free if not necessarily. So just I guess just use it and they are willing to do it for you. Yeah, contrary to what people think, they are not here to make money. They cannot are willing to help us actually save money. So yeah, this was about making things right, and now I will talk about making things fast. So remember this slide, right? So it's like different queue and different patterns, and we focus on this one. That's just something like it's a regular. So when you zoom into it, you can see like this pattern. So we have a service. It's a cron job actually that just send like every 6 hours. You can see like every 6 hours there is like some. So this is why we have this pattern. So it's like sending it to this queue, and we have like so this queue has an issue, and this was the issue. It's how do we make freshness. Who knows about freshness? Freshness is how fresh is your data in your database. So, yeah. And the goal is like to offer the most up-to-date data as possible, as fast as possible for all our users. The problem is that if you decide project data were a little bit updated, so there was like some issue about it. And yeah, so we need like analytics faster. Some customers were complaining about it, and this was actually, so this is a graph about one of the consumers, one of the consumers that are processing this queue. And we can see like basically it's like take like up to 4 hours, like all the messages. And 4 hours, okay, slow is fast. Anyway, so that was the metric. And so we have the worker that was doing this, and basically people understanding this thing? Yeah. Like Kubernetes is a different type. So we just set like basically on down, you can see like there is 45 pods that are processing this queue. So this was basically the setting that we have for this service. And what's the problem about this? Okay, that's a open question. I don't know if you heard. So is there a problem about doing this or this kind of queue? No problem? I wish someone said something. No. Okay. 2 problems. So when you have like 45 workers that are processing nothing, you can end up with what I was talking about before about doing nothing, right? that's the problem of it. So there is like 45 workers there, and you could like just remove them from your cluster. They're just doing nothing. Right? Yeah, that was how it was like. Oh, so it was you just someone said, oh, 45 workers and just keep running. Right. So and the other problem is like developer when they set these settings. I mean, I didn't really know how to do it, but the problem is like you just try to not put too many workers. I don't want other workers, this kind of thing. So you try to put just enough to process through as fast as you can. The thing that you don't want to put like just maximum because 100. I mean, 100 worker will just do nothing for 20 time, right? Does that make sense? Does that make sense? So I just mean like if there is 100, if you put like a too high number of workers and there is nothing to process, so it's like a waste of space in the cluster. Yeah. So people are like trying, okay, I will have not too much, but not too low either, and just compromise between. And this isn't great. Right? So how to solve it? So autoscaling is the issue, is the answer. So basically, you just pick the message of the queue. Say, oh, we have message actually in the queue. Just say, all right, autoscale how many workers you have. So for this, we use Keda. So I mean, there is like the auto pod, autoscaling use, but it was like a little bit tricky because I didn't know how to read the queue and I had like to make some code, and I don't like to make too many codes for. So I was like trying to find the tools to do it, and it looks like that was a solution. And this is all I was asking around before. So what is good is like not only using for SQS, it's for Kubernetes, it's for Kafka, it's for any kind of event you have. So you can read everything like really easily. So it's really easy. So you just like provide your keys, or you can set up some models here. Just say, okay, you want to manage deployments, and you can say how often you want to put this people, how many queues there is, how many messages there is in the queue. Just say, oh, if there is like one, yeah, just say like, okay, if there is like 100 message, start to trigger the scaling. And it's really easy. You just set your maximum and your minimum, and Keda is doing like this magic for just stuff. And what is nice is here's the result. So you can see like before like 45 workers that the developer set. Here, 45. And you can see it is here. And here you have the message, the number of message visible. So every time there is like so before it was like really linear. Now every time there is like a spike of messages, you can see like the number of containers. Here's the number of containers, sorry. Just following the trend. So it's very nice to see. And we can also see like memory usage and yeah. So after we did this, we saw 30 that were faster. Because what happened is like, okay, so they didn't want to do this compromise about, okay, we just workers. Just say, okay, so now we can like, we are now, if we figure like 100 workers, it will be used one. So it's why like, you can do this. Can see the results. And yeah, the thing is that there is a problem about here. Anyone see anything? No, but yeah, for instance, yeah, I mean, this is just a number of messages to see. So this is what happened before autoscaling. So before, you always have the constant number of pods. You can see like this line is going like just going down continuously, right? This happened after autoscaling. So what's the problem? Anyone see the problem? Sorry, I never did it.
So what the message start to scale down for all of it.
Yeah.
So there is a very
Yeah, exactly. So this is the part to notice. Part here. So why isn't it like just going down? Why is it like still having some message? Long tail. There is like this long tail here that great. So I just watched it and almost didn't even notice it. And the thing that is quite a long thing, like 65 minutes of long tail. Keda causes. Keda because I will explain to you. I mean, I think you point is like because Keda is like downscaling the workers. I come to you just later. But yeah, the problem was like this long tail lasts like 65 minutes, and we could like usually just like wait and just 5 minutes almost. So what's happening? So there was a guess. This is the number of messages visible. This is the number of workers, and you can see that the number of messages start to kind of pattern. This is a word I don't know. With the number of containers present. So we have less workers to do the job. It was one of the consequences. And but the thing is that I mean, it could have that I didn't really understand like why is it that long? Just have that enough workers. Like this. And this is the problem. So what do Keda? Keda just say, oh, so now we reach like this amount of we don't need like that many pods, so we just execute pods. And so we have less containers, and so Keda will start to kill pods. Problem is like when you start to kill pods, your service need to handle to say, oh, Keda says Kubernetes to the pod, so we need to handle that. The problem is that we are not handling that. The thing is that we have like some messages that were being tested. The thing is that Kubernetes was just killing the pod, and those messages return into the queue. And this is the problem, so we are like not managing. Did that make sense? I think I wasn't good at explaining this thing. Maybe I just go here. Yeah, so the worker didn't manage the seek term. Now, seek term signal is like when Kubernetes, Keda was telling Kubernetes pods, and Kubernetes send a seek term signal, right? And so this is sent by Kubernetes. The problem is that it was kept like being processed. So and after like it was just halfway processed, and after like back when Kubernetes was like, all right, this is enough time for you to shut down your pod, you can do your job, but we just kill it. And so the message that was inside this queue returned to again because it was not deleted, not processed. Yeah, that's what I said. So, but the problem is like we also have less worker. So the thing is that it's kind of created like a kind of we have like more messages, but we have less. So this was like that was the problem. So the solution was basically to just handle the Kubernetes signal. So when Keda said to Kubernetes, okay, we need this pod, you send a signal, and you have to handle your code. All right, we receive this signal, so we should stop processing messages and accepting messages, just let it go and just let it. So yeah, so just unleash the pod and set a graceful period. Yeah. Who knows about a graceful period in Kubernetes? The non-graceful period is like when you say Kubernetes, okay, you have that much time to finish your process. So by default it's 30 seconds, but I mean, if you have a worker that do something, it could take like 60 seconds, 105 minutes, I don't know. So you should like set this period here. So two things to do, and yeah. So So this is like really important. This is like about so yeah, basically just say okay, stop messages or stop message requests or this kind of thing. So it's why it's really important for you. And so after this, we just see this, and basically it's just like doing just straight down, and just we don't have like this tape anymore. So yeah, so the result that was like yeah, and it also helped like this auto scaling thing of stages, so you don't have like more workers that are doing like yeah, it's really really easy. So yeah, it was like about making things right. Thank you. That was me. Yeah, so we had some tracking in Datadog. So each message are processed. We use Datadog, Datadog. Yeah. So each message are processed, we know how long. So we just take the maximum and just say, oh, so this is maximum. Like 30 seconds more. So.
Right. So usually we start coming to change the part. So we start coming.
I don't know about it, so maybe it's a good one. Oh yes, I didn't know. It's a good one. It's a good one. But yeah, it's yeah. Yeah. Yeah, it's a really good one. Yeah. Yeah, so this is I think one of my next projects. Yeah, because the thing is that we have so we just have the maximum we just know okay so we can set that many pods. So the auto scaling should be counted to have, right? And there is like a project Keda or something. But yeah. So that's also you have this problem. So I will be happy to talk to you later because I don't have this issue and then we work on it. So yeah. Yeah. Oh yeah. I totally agree. Right. Yeah. So just ask me a question add me on Twitter. So add me. Yeah, you can. I wrote some articles on my blog post too. I wrote a big one on the limits too. If you are interested into it, I think it's quite interesting one. It's quite controversial. I hear. I didn't know it was that controversial, but yeah. Anyway. Thanks.